Hello, good morning, dear learners. Now I'm going to discuss about how to design high order multiplexer with the help of lower order multiplexer. Like here we have taken example where we are going to design 4 cross 16 multiplexer with the help of 5 4 cross 1 multiplexer. So since we have to design 16 cross 1 multiplexer, so this can be written as to the power 4 cross 1. So you know that this exponent of 2 is going to give us number of selection lines. So here number of selection lines are how many? That is what? 4. And now we are going to design with the help of 4 cross 1 multiplexer. So 4 cross 1 we can write to the power 2 cross 1. Now here exponent value is 2. So this 4 cross 1 multiplexer will have 2 selection line. How many selection lines? 2 selection lines. So with the help of 4 selection lines in case of 16 cross 1 multiplexer, you will see that total how many combinations are possible. So here left side I have tried to show you the all possible combinations with the help of 4 selection lines. So that selection lines here we have S0, S1, S2, S3. So finally, if you see that 16 combinations are possible. And here those 16 combinations, how we are going to implement when we are going to use 5 4 cross 1 multiplexer. So let's see if it is only 116 cross 1 multiplexer, then what is the situation? So in case of that, what will happen here? Input will start. That is the first we represent as 0, second we represent as 1. Like this, it will have total how many inputs there? 16 inputs will be there. So that counting will go from 0 to 15. And in case of multiplexer, you know that it will have only one output. But it has how many selection lines are there? 4 selections lines are there. So those selections lines will be here that we represent in the bottom. So that name we have as we always start in the binary with 0. So this is the S0. This one S1. This is S2 and this one is the S3. So now same phenomena we should get here when we are trying to write this one with the help of 5 multiplexer. So here if you see that at the input stage, we have taken 4 multiplexers. So these are the 4 cross 1 multiplexer. So how many we have taken? At the first stage, we have 4. And finally, output of these 4 multiplexer is going to combine with the last multiplexer, that will be our 5th multiplexer. So now here the important thing is that how we are going to give selection line as the inputs. So since it is 4 cross 1 multiplexer, so each multiplexer will have 2 selection line. So this S0 and S1 is going to be the selection line for this initial first stage 4 cross 1 multiplexers. So whenever this combination of selection line is going to change, according to that it's going to select the inputs. So here, so we are going to write this one as the I0. This is next will be I1. Next will be the I2. And next is the I3. And here for the first stage, we are taking the common selection line S0, S1. So that from LSB side, 2 bits we are taking as the selection line. Now, if you see in the connection part here, we are going to connect the selection line to each multiplexer. So this S0 is connected here. Again, S1 is also connected. And same selection line we are going to use for the other multiplexer also first stage. So S0 and this is our S1. Like this, here also we have to connect. This is the first one is the S0 and second one is what? That is the S1. So this is the basic things about which you are already aware. So just we have to implement here in case of 16x1 multiplexer. So finally, for each multiplexer, we have given input here. So now, if you see that in the initial stage, if we have a combination 0, 0 from here, that you know that it is going to select the I naught. If it have 0, 1, it is going to select the I1. When we have 1, 0, it is going to select the I2. When we have 1, 1, it is going to select the I3. So now, what will be the output here and what will be the input for the next multiplexer? So here we'll have one output since it is 4x1 multiplexer, and that output is connected to the fifth multiplexer. Now again, for the second multiplexer, what we have here in the input side, for that again we'll have 4 inputs. So those inputs are represented here. This is the I4. Next we'll have I5. Next we'll have I6. And next is what? I7. Again here similar condition. When we have 0, 0, like this is output is going to come, and output of this multiplexer is given as the input to the 4x1 multiplexer here. Again, for the third multiplexer at the first stage, we'll have 4 inputs. Those inputs we are going to write as here I8. This is the I9. Next we have I10. Next we have I11. So similar operation for this multiplexer also going to take place. And again we have another one, last one of the first stage. So it also having 4 inputs. So those inputs are again, this one is here, I12, I13, I14, I15. So total 16 inputs are here. So previous multiplexer output also will be connected here to the last stage 4x1 multiplexer. And finally again here, this multiplexer output is also going to be connected to the 4x1 multiplexer here, and it will have a single output here. Now it is important that what is the selection line of this multiplexer. So selection line of this multiplexer will be S2 and S3. Now we'll try to understand the operation, how it is going to work. So now if you see that here in the initial stage, for the combinations what we are going to take here, so we have 4 combinations, 1, 2, 3, 4. So up to this S2 and S3 combination is what? 0. So when S2 and S3 will be 0, here we can mark the multiplexer like this is multiplexer 1, this is the multiplexer 2, this is one multiplexer 3, this one multiplexer 4, and this one is the multiplexer 5. Now, what is the basic operation here? Now we are going to see. So now when S2 and S3 both are 0, then this multiplexer 5 is going to take input from the first 4 cross 1 multiplexer. From where? From the first 4 cross 1 multiplexer. So here S2 and S3 is the 0, and here this S0 and S1 is changing. So this is 0, 0, 0, 1, 1, 0, 1, 1. Like this here, I0 will pass, I1 will pass, I2 will pass, and I3 will pass when both S2 and S3 is the 0. Now, another combination what we have here, second combination, if you see here, for the next 4, this S2 and S3 combination is what here? 0, 1. So when here we have S3 as the 0 and S2 as the 1, now it will take input from the second multiplexer, second 4 cross 1 multiplexer. So again here S3, S2 will be 0, 1, and this value of S0 and S1 will be changing here for the second multiplexer, and it will select the outputs from these multiplexers I4, I5, I6, I7 on the basis of this combination 0, 0, 0, 1, 1, 0, 1, 1. Again, if you see that third situation where we have S2, S3 combination, so that is this is the 1, 0. When it is the 1, 0, it is going to take the inputs from the third 4 cross 1 multiplexer. Again, here similarly for S0, S1 have 4 combinations. On the basis of that, I8, I9, I10, I11 will come. And finally, we have last one here. So here if you see that in the last one, S2 and S3 combination is 1, 1. Again, this is going to change. S0, S1 is changing same as before. So again, when S2 and S3 both are 1, now it is going to take input from the fourth 4 cross 1 multiplexer. Like this, we are, and here whenever we have 0, 0, again you know that it will be going to pop out the, what is the input here. When we have S2, S3, 0, 1, it will take from here, 1, 0 from here, and 1, 1 from this point. So like this, we are able to implement 16 cross 1 multiplexer by using 4 cross 1 multiplexer. So this question is very important for the university exam purpose as well as conceptual based in the GATE exam also. Sometimes they can ask you how many multiplexer 4 cross 1 multiplexer is required to design the 16 cross 1 multiplexers. And some other combinations are also possible. So if you like these videos, so please you can like it and again pass to the other learners also so that it can reach to the maximum people. Thank you. Thank you.